Hi everyone, I'm Eve Young, and today we're going to have an Xcode exploration on the drag and drop API. Also, for a better illustration, we're going to use an open source iOS application called Kanban Board, which was developed by Alfian Losari. So let's begin with an overview of the drag and drop API. Drag and drop API is a collection under UIKit that allows the user to drag and drop items such as images, text values, cells, or other objects within one application or even across different apps. So based on the name, we could potentially have two major actions: drag and drop. And accordingly, the code implementation should also contain two parts: the source, also the destination. Is it true? Now let's dive into the real application and code to find out. Okay, let me turn this into full screen for a detailed look. So Kanban board is actually a project management application that helps you to track the progress of current project. And we can see three different lists in this view: to do, in progress, and done. Within each list, there are a list of items. There are buttons to add new items, and also there's a plus sign to add a new list. Now let's check out the drag and drop features. If you press and hold on one certain items, let's do storage management, you could simply lift it up and reorganize it to some other locations, or even drop it to some other lists so that you can mark storage management as in progress, or we can mark analytics as done. Also, for another scenario, when you click on one of the items, let's do push notification, and you will notice that on the top left corner, you will see a delete button showing up. When you move and drop the push notification item on delete, it will disappear. Now let's get to the backend codes to check out how these two usages are implemented. So first, let's take a look at the overall file structure. In main file, we can find the GUI interfaces and views. The whole screen was implemented under a collection view, which coordinates with a data source and delegate to display a scrollable collection of cells. Each cell in the collection view is a UI collection view cell object. In this case, the three project stages. Also, we can easily find out that the list of items are implemented in a table view. Then we have board file representing the class board for each phase. Also, we have the collection view controller, which implements the overall interfaces, like the three blocks, buttons for deletions, add items, and add lists. Finally, we have the collection view cell file, specifically dealing with the table view, showing the list of items. So for the first drag and drop scenario, which is reorganizing an item inside or across the table, we can refer to specific documentation on adopting drag and drop in the table view. So first of all, we have to enable drag and drop interactions in view load. Then we need to implement functions to provide data for drag section and also consume data from a drop section. Let's get back to our code. So in collection view cell file, we have the initialization code in setup section. The Boolean value drag interaction enabled is one big switch for the drag drop action, and here it should be set to true. This can also be set up in the main file. We select the table view and also add the check mark in the right side menu bar for user interaction enabled. Also, here we connect the table view and drop the table view drag and drop delegation to actual functions and methods defined later below. Here we have the required UI table view drag delegate and the UI table view drop delegate. In drag delegate, line 94 to 104 have the compulsory function, which takes parameters like table view source, in the session for the drag operations, and also the index path which indicates the specific item that's being selected right now. And line 99 indicates that the track action is actually extracting a string value behind the item. Then the following two functions define the interactions with buttons from the collection view controller while you're dragging or the drag action ends. Let's put up the simulation again. We will see that when an item is being dragged, a deletion button will show up in the left corner, and also the plus sign will disappear on the top right corner. Vice versa, when we drop the item, the add sign will show up again and the deletion button will disappear. So now we have the desired interactions and delegations for drag activity. Let's do the drop part. Here we have a method with perform drop width coordinator. This delegate method is the only opportunity for accessing and loading the data representations offered in the drag item. The drop coordinator supports accessing the drop items or updating the table view or any other specified optional animations. So first, we use a guard statement to make sure the selection is a valid item with string values. Next, the actual interactions, we use a switch statement to identify different cases based on the source and destination index paths. When moving inside one table view, we start with the table view.begin updates and also do remove old items, insert a new item, and then reload the rows. When moving across table views, similarly, we remove source table data and then insert the item to desired index in another table view. And for the second scenario, which is drag an item and drop it to the deletion button, we have a more general implementation for adopting drag and drop in a custom view, in this case, to the button. Similarly, we need to attach the interactions to the expected views and then do the drag session, also the drop sessions. So as for the drag session, since we've already defined the drag delegation for items in table view earlier, there's no need for duplicate implementation. But for the drop session, we do need to define the behavior when drop on the deletion button. Here we have the UI drop interaction delegate. The first method defines the drop interaction during a session called session did updates, which is in the middle of your drop activity, and this helps configure the desired behavior on your interactions. So for operations, we have cancel, copy, forbidden, and move. Here we're using move, which means you're moving an item from one place to another. And for copy, this will leave another copy at the source place. For forbidden, it will show you a notification that the item you're selected is forbidden to move. Next, we define another drop interaction method during the perform drop session, which is for when the drop action is actually done. So inside, we update the table view again using the table view.begin updates. We do the data source item removal, also delete the original rows in the table view, and then end the updates. In the end, we have to attach our delegation to the custom view, which is the button. So here we add the linkage between the button and the drop interaction by doing button.add interaction and add the UI drop interaction we've defined in the bottom. So that's pretty much everything we need to implement the drag and drop interactions. for this application. In the end, let's get back to the question we have at the beginning. Does the drag and drop API really have to do separate implementations for the source and destination? My answer is no, not necessarily. When dragging the item from the list to a deletion button, we do need to write delegation code for the source and destination separately. But when we're moving the item inside one or between two lists, source and destination kind of having a blurred boundary since they are in the same type of view. In this case, there's no need for distinction or separation in the actual implementation. That is all for today's short exploration of drag and drop API. I hope you've learned something today that could be useful in your future iOS development. Thanks again for watching this video and stay tuned for the next one.